And welcome to the Landtamer stream. We're going to be talking about, we get a brief vlog, excuse me, tonight, and then one link of the day today, and then we're going to do an OSPF pop quiz, I'm calling this. Good stuff. This may just be the last OSPF lab for a while, unless we do some review, but this is the last quote-unquote lab of this section, so anyway, for today's activities, not much going on. I did do an earlier vlog. I live streamed some commentary I did after attending the WebEx for the VIRL 1.3 release. You may have seen that. Just an update. That's also my link of the day. There's one link of the day, and they did release, and I'll include it in this video. And the Cisco Learning Network actually did release a page that has the presentation that they did, the slide deck anyway. And you can download those if you want to see any detail. I mean, probably not a real major reason to, unless there's something in particular you're looking to find out about this release that I haven't already covered in my earlier video slash blog. But you know, the presentation does have a lot of details. At the end, I didn't see this part, but they did, I guess, a sort of demo. They have not released it yet. I've looked to see if that's what we're going to be doing tonight. Did not see a release out yet, so it's probably going to be tomorrow before we do anything with that. But anyway, that's the presentation. That's the slide deck. If you're interested in that, you can download it yourself. You do have to register, be registered in Cisco Learning Network to get that. But that's really all I have for vlog. I didn't do a lot of reading. I did not do a lot of reading today outside of Cisco documentation. I did do some reading of Cisco documentation because, and we'll talk about this lab. First of all, my disclaimer, and I'm going to start doing this more often just to, out of respect, you know, this, when I say this lab, this is not my lab. This is, I am trying to perform a lab exercise that is done by INE. So this is out of the INE workbook. I highly encourage you, if you have not yet, they have great content, endorse them, check out their, you know, packages, sign up to get their, you know, purchase a package to get their workbook or their videos if you don't have them already. That's really what I'm going off. This is their quiz that I'm going to try to see how I do today on. So this is kind of a good summary. And when I first read the requirements of this, I was at a little bit of a loss. So it tells me I may need some more practice. I may build some of my own labs after I do this just to practice this some more. And here's the gist of it. There's a map that there's a separate diagram for this. And let me pull it up here. Thought I had it already. Load it somewhere. I guess I don't. This is not the drawing right out of the workbook. I did my own drawing in Visio and just enhanced it a little bit for the purpose of this lab on the stream. It looks simple and probably is simple to people who experience an OSPF. But for me, it threw me off a little bit, and it made me go back and read some Cisco documentation again. In particular, the OSPF, what is it called in the configuration guide? I'm pretty sure I have that open. I had to go back and review this document. It's in the technology section. So you have to go support all products or categories, be all products. Some kid is yelling outside. Technology, IP routing, IP routing. And this is a design tech node, I think. Go under OSPF. OSPF database explanation guide. I love this guide. I've raved about it before. Walks you through the LSAs, and I had to go back and look at this again because at first I was somewhat stumped by this, because what they're saying is you have loopback 5.5.5.5 on router 5. This is a different topology than what I've been showing, the other INE topology, which is basic OSPF addressing. This is a special topology just for this well, in the workbook, it calls it OSPF Path Selection Challenge. I call it a pop quiz, right? Let's review. How did you do? Now we're finishing up OSPF. Test your knowledge. So what they're going to do is in this router 5, we have this loop back, and this gets redistributed. Well, actually, this is running EIGRP here between routers 5 and router 1 or 4. Then router 4 is going to redistribute. It's going to do mutual redistribution here. And we have router 4 has a link in OSPF area 2, which is a not so stubby area. And it has a link in OSPF area 1, which is a regular, it's a normal area 1. The cost here, though, is 10 to this link, and the cost here in this NSSA is 100. Then you have your backbone area. Router 2 and 3 are in the backbone area. And router 1 is also in the backbone area, and there's a cost here of 10 and a cost here of 100. This looks like point-to-point links. I'm not sure that it is. I think it is. I have not actually put this topology in VIRL yet, but I may. I have fired up VIRL and this simulation, so we might do this. But essentially, what it's asking me is, okay, for router 1 to reach router 5's loopback, which path will it take and why? This looks like good lab stuff, right? Something like this in CCNP, I think I remember. For router 2 to get router 5's loopback, which path will it take and why? Right? And then for router 3 to get the router 5 loopback, which path will it take and why? And then it's going to throw this at you. There's 4 questions on here. The fourth one is, if router 3's interface to router 1 goes down, how did this impact router's 1 path selection to router 5's loopback? This seems kind of simple, number 4, but the hardest one to me to get my head around was this one, number 1. So I figured, you know what? For this, why don't I start with the easier one? And for each of these, I'm going to approach it as, first of all, what LSAs will be in the database for that router? And what is the metric for each available path? So router 2 could potentially have, he could potentially go through router 1, or he could go through router 4. So let's say for router 2 to router 4, what will the OSPF database look like? So router 4 is doing redistribution. And so this is going to be an external route, correct? And by default, it'll be a type E2. Well, I say E2. We have here a not so stubby area. So what that means is router 4 is going to generate a type 7 LSA. Router 4 generated LSA type 7. Got some chats going on. Hey, Diviso, how's it going, my friend? Good to have you on tonight. Hope you're chugging along, man. Chugging along. We're about to hit BGP. In fact, this is the last one I have in the OSPF workbook, INE. And hey, how are those switches upgrades going? Those 5Ks. Did they finally? Last time I talked to you, you were trying to get your server people to. We were trying to teach them how to shut down virtual machines. My work has actually been not too bad, fortunately for me right now. I did have a deadline that had to be due by Friday morning, some F5 work, but I figured out I use Excel to generate some scripts, and I was able to get my stuff built. Oh, good job, man. Good job on those 5Ks. Whew. There's certain projects you dread, right? And when you get those finished, you're happy. Yeah, I was able to get my deadline done by Friday, so I don't have to work tonight. So I'm able to continue the lab, which is good. I go through periods of work where um, I'm working 68 hours a week, 80 hours a week, but that's rare. It's only in certain, maybe a few times a year I'll go a week or 2 or 3 weeks where I'm working 80 hours a week to meet a deadline. But most of the time, thankfully, at this job, I get time to lab, which is good. I even get time during meetings. I was in meetings all day long, and I was able to actually catch up on a little reading while other people were talking, which is nice. Oh gosh, yeah. And you probably had to wait for them to bring it back up to make sure to validate everything was running. So you had to just sit there, try not to fall asleep, I'll bet. I'm glad that project's done for you, my friend. Don't forget about labbing too. Hopefully you get a little time to lab or study. But yeah, we're cranking on this OSPF, and this particular lab is I'm calling it a lab. It's really sort of a pop quiz exercise. Again, what we're going to do here is we got to figure out these. This is testing my knowledge. So I'm going from router 2 to router 4, and we know that router 4 is going to generate a type 7 LSA. And the LSA is going to say the router or advertising router is, I'm going to assume it's 150 or 4.4.4.4. There are separate configurations for this challenge that I can put in the lab. I may not need to do it. It is 4.4. I have not loaded this stuff. I have not put it in VIRL. But we might if I get stuck. So we've got an LSA type 7, and it is advertising 4.4.4.4. So if I'm our router 2, I'm going to see this, and I'm going to see what is my cost to reach this advertising router. First of all, remember that if router 4 is doing redistribution, and let's look at the metric, because I'm pretty sure I'm going to use this LSA type 7. And an LSA times 7, I'm going to try to recurse to the advertising router, and that is going to be an LSA type 1 in my area. The 7 is going to have a cost. The redistribution metric is 20, right? So these are the LSAs. Now what is the metric? I'm going to say 20 plus 100, right? Because that's my cost. That's my cost to reach. So we're going to say the metric is 120. And this is going to be what type? It's going to be an N1 or N2, sorry. N2. Now let's look at my other path. My other path for router 2 to get to this loop back is in area 0. I'm also going to have an LSA type 5 coming from area 1. Because let's walk that through. This is going to be redistributed into area 1 as a type 5. This is a normal area. There's no 7 to 5 conversion. It's going to be as a type 5 E2. So it's going to have a metric of 20. And then let's write this out. This is path 1, right? Path 1. This is path 2. So this is going to be router 3 will be an ABR. And he is going to advertise the type 5 into area. He's going to flood. There'll be no conversion. So he's going to also flood this into area 0. Now the question is on a type 5, what is going to be the advertising router ID? In this case, we are going to have okay, so we're going to have type 5. Advertising router will be the original router, right? Because we're not doing any type of conversion. And unless we're filtering that out, which I looked, we're not. If we're not removing the forwarding address is going to be the router, the same router. So then what I need to do, if I am router 2, is I will need to look at a summary route because we have an area border here. So router 3 is going to advertise a summary address, which is a type 3, or 4.4.4.4/32. And that is essentially going to mask whatever the reachability is to 4.4.4, right? So router 2 is going to say, all right, 4.4.4 is a type 3 via this ABR. So the advertising router is router 3. So then I need to look at my LSA type 2, my network, for 3.3.3.3. And actually this is not, yeah, I think the way it actually works is I look at my type 1 for 3.3.3 and I look at the links that it has. And then I calculate a cost to using those links, right? And if it's not the same segment, then I have to also consult the LSA type 2, the networks. So we're going to see that basically this cost is going to be 120. So the metric will be, we've got 20 because of it. It's an E2 when it gets to router 3, so it's going to be 20. It's not going to add its cost to reach. That'd be a type 1, right? So it'd be 20, and then it's going to be 110. So the metric will be 130, type E2. Okay, so router 2 is going to look in his database, and he is going to see a type N2 with a cost of 120, and he's going to see a type of E2 with a cost of 130. So which route does he take? My opinion, I think what it does is anytime there is an E2 or an N2, it compares the cost of each and selects the better path, the lower cost. So in this case, I think the answer is R2 to R4. It looks simple, right? This is closer, but if we actually do the shortest path tree, we find that they're actually pretty close in cost, only a difference of 10. And I could be computing this incorrectly because the cost is 100. Do I add any cost here? I don't think so. That's what I'm going to go with. All right, so we've got this one. Now let's go to this one is the next easiest. And sometimes this is like an exam, right? Sometimes you get these questions and you got to look over the whole thing and think, okay, where do I start? Do I start with the most difficult or do I start with the easiest? Get warmed up. I tend to go with an easier calculation and work my way from there. All right, so router 3. This looks obvious, right? Looks like this would be obvious which way it's going to go. But let's try path 1. Would be R3 to R4. And of course to R5 after this. This is the same link no matter what. So R3 is going to have a LSA type 5 with the 2 with an advertising router 4.4.4.4. And then what he's going to do is he's going to consult his LSA 1, and he's going to see a router LSA there for 4.4.4. He's going to calculate his costs to get there. So those are the 2 LSA types he's going to use. The metric, well, the redistribution metric is 20 by default, and plus 10, 30. Okay, now how's it going to look if we go this way? Path 2, router 3 to router 1 to router 2 to router 4. All right, we already know that this is going to generate an LSA type 7, and then this will be converted to an LSA type 5 in area 0. I think we did that calculation already, didn't we? LSA type 7 advertising router. No, let's go through this. So R2 will have an LSA type 7 that he will convert to an LSA type 5 with the, and he essentially will become okay, in this case, router 2 is going to flood a type 5, and the forwarding address, all right, let me think about this. The forwarding address, when you have an NSSA, are you going to generate a type 4, an ASBR? Okay, I have to go back to my, let's go back to this document. I was referring to this earlier. This is where I got stuck earlier. So, shoot, mouse is getting low, battery. Here we go. This is a good document. Okay, is it not so stubby? No, it's not. There is another one though. Where is the other? The OSPF database explanation guide. Okay, this is it. Oh. So we have our NSSA area, and we have a type 7 and a type 5. Okay, so yeah, so what's going to happen is router 2 is going to flood a type 5 into area 0. However, because we know a not so stubby area is not going to receive type 5s incoming, well, I thought I had it figured out. Hold on a second here. So here we have our example. And then we have to go down to router 2. Okay. Yeah, so show IP OSPF database external. This is what the 5 is going to look like in area 0. Yeah, it's going to say router 2. Right. Because this is a not so stubby area, we can't make assumptions about reachability to this router. So what happens is he becomes essentially the ASBR, the forwarding router from a not so stubby area. Yeah. So router 2 becomes the forwarding address for 5.5.5.5 when it floods into area 0. So the LSA 5 advertising router, and this is into area 0, is going to be 2.2.2.2. So then from router 3's perspective, he's going to see LSA 5 advertising router type 2 or 2.2.2.2. So then he has to look at the LSA 1 or 2.2.2.2 and calculate a metric to that. And that is going to be 100 plus 10. Well, first the metric, the redistribution metric is 20. That'll be in the LSA type 5. And then the forwarding metric is going to be 110. 130. So we got the same result as if we would go this way. So for router 3 to get to router 5's loopback, he can either take this path, which is a metric of 30, or he can take the other path, which is a metric of 130. So we have our answer. Which path is going to take R3 to R4? Okay. So now let's take on this one. Router 1 to router 5's loopback. These should actually be the same, right? In area 0, well, no, they won't. The database, we've already calculated the database. Now we just need to calculate the cost, right? So we already know that for, let's see, R4 to R2 to R1, that will end up being an LSA type 5. It's going to get converted 7 to 5. And that will have a metric of 20. And then from R1's perspective, the advertising router here is 2.2.2.2. So now he consults LSA type 1, and he'll figure out that the metric is 10. So the total metric for this path is 30, which is interesting. Now, if this were an LSA type 1, we would also include this cost, and that's one of the downfalls of an E2 versus an E1, right? But this will be an E2 with a total metric of 30. Now let's calculate path 2. This is path 1. Path 2 will be R4, R3. And I'm counting backwards. I know when I put R4, R3 to R1, because that's how you work the LSA types, right? So this is a normal area. So it's going to be, there'll be no conversion. So it'll be LSA type 5, LSA type 5. In this case, though, the advertising router, the forwarding address is going to remain 4.4.4. So we'll have an LSA type 5 in area 0 with a forwarding address of 4.4.4.4. Then we will consult an LSA 3 to this destination, and we'll see, we'll get there by way of router 3. So advertising router. Now there will be also, actually I need to think about this. He's going to advertise a summary as well to 4.4.4. But again, this is converted, so the forwarding address is different, right? But here, we're still going to have 4.4, so we consult the LSA type 3. And that will say your advertising router for 4.4.4 is 3.3.3 by way of continual recursion. And our cost is we're going to find out is the metric of an E2 is 20, plus our cost to get there is 100. So our total metric is 120. So between those, we would take R1 would go to R2 to R4 to R5, right? All right, at this stage, and then there's one more. Router 3's interface to router 1. So let's say this interface, right, goes down. What will be the impact to router 1's path selection, router 5? Based on what we already know, is this a trick question? That's the first thing that comes to mind. Is this a trick question? Not really. No, because already using the preferred path. Man, that just tells me that there's something wrong here that I'm missing. But you can't read too much into this, right? You go nuts. So I could just go ahead and look at the answers, but I want to lab this up. This is probably the only lab we'll be doing tonight. So let's go ahead and lab this up. Now in my topology, what I'm going to do is I'm going to stop these routers. We don't need them running. So I'm going to click on each individual node here and stop them. We're only going to use routers 1 through 5. And then let me open the configuration, the new configuration for this. The INE path selection challenge. Good stuff. Router should be running. I'm going to check and see if you can see my super cool on the window here correctly. It's a little off. There we go. And I need to use this really cool TCL script here that he gave me. on these routers. Let's open 2, 3. Don't need to open all. Let's see if we were right. Oh, look at that. We are back to our default configuration here. And I noticed one thing on this, that in this little selection challenge, the interfaces weren't exactly jiving up here, so jazz 01, jazz 0, 1.12. All right, let's see if that works. Far so good. That says no shut. That's okay. Gigabit Ethernet? Is it something it doesn't like there? I don't know. G0/1.13. There we go. Okay, router 1 is configured. Now let's go to router 2. Okay, I think we can just take this whole thing. Oh, I didn't do the replacement on those yet. All right. All right, router 5 is ready to go. Let's pull him up. Pretty simple configuration here. Cool, router 5 is ready to go. Okay, router 2 is ready to go. Do router 3. Cool, we got OSPF running there. And we'll do router 4 as the last one. Router 4's got a bit going on here. Just search and replace on that. Okay. He's got the longest configuration because he's running 2 IGPs, right? Yeah, it looks like that all went in. Awesome. Okay, got a configuration. So let's go back through our little exercise in madness here. Let's do the number 2 first. Router 2 to router 5, which path and why? Let's look at router 2. Show IP OSPF database. And first of all, we said there'd be a type 7. So that's going to be NSSA external. Oh, oh, it's still coming up. Yep. Be patient, Gwen. Good time for you to drink of water. You know, if I had to do it over again, and I had the knowledge I have at the end of the OSPF section, I would have started the OSPF section, and I would have changed all my timers on OSPF. Help with my impatience. Because, man, it takes a little time to converge. Okay, now, Shopee, and there it is. So we have, all right, there, I already see a couple things I was not expecting. First of all, router 2 says it has 2 type 7s. And one is area, yeah, both in area 2. But it says no type 7 to 5 translation. Now, why is that? Why is there no type 7 to 5 translation in a not so stubby area? Show run or show IP OSPF. Supports not so stubby area. Here's our areas, right? Backbone, 1 interface, 8 LSAs. Area 2 is an NSSA area and perform type 7 to 5 LSA translation. So let me look in, yeah, that doesn't make sense. Anyway, we're not, let's not get ahead of ourselves here. It says router 2 to router 5. We should have a type 7. We do. And the type 7 says that the advertising router is 4.4.4.4. It looks like we have 2 different links. We have a 45 and a 5.5. This is the one I'm interested in. Yeah, you can. I heard about that. I think you can do that. Can't you do that in VIRL as well? Because it uses QEMU, apparently. I don't know. I don't know much about it. Um, and I'm not sure what reason would you do that, I guess. Visual. He's commenting, wow, GNS3 team where you can run a Windows image from within GNS3. Yes, I did see, what's his name? David. It's one of the links. I posted a link by him. I like where I will say I like where GNS3 is going. I may still end up using GNS3 at some point. You never know. David Bombal, Bombal. If you guys have not checked out his channel, um, man, he has an awesome channel, and he had a GNS3 Windows QEMU appliance now available. That was 1 day ago. Good stuff. It's probably great news for a lot of people. I myself don't see where you might use it, but again, I'm not a GNS3 user, and shoot, maybe there are some really good use cases for that. I guess I could see, sometimes you want to test like Windows DNS. If you see, I don't do a lot of server stuff. Only benefit is I don't have to run VMs, one for GNS3 and one for a Windows 10 VM. Two VMs, right? Oh, okay. So I see what you're saying. So let's say you have a Linux machine or you have a Mac, and for whatever reason you need to run GNS3 and you also need to run a Windows application or something else. Well, now instead of running, um, having to run another virtualization platform like OpenBox to run a virtual machine or VMware View, you can now run that right inside of GNS3. So yeah, I can see that advantage. That's pretty cool. Obviously, I have a use case for it. The fact that they um, spent enough effort to make that happen. I think one day, um, I don't know. Good stuff though. I like what they're doing with GNS3. I like that they keep developing it and making it better, adding new functionality to it. It's pretty awesome. Yeah, test for traffic. That's true. Um, I know a lot of it, the exams you test with, you kind of use a router as a PC, but it is kind of nice sometimes to test things using Windows, especially if you're trying to test things in production, right? Maybe you're trying to do um, maybe you're doing a proof of concept and it's a Windows app and you want to see what impact it might have on the network. Yeah, absolutely. Definitely see use case for that. Pretty cool. They keep doing stuff in GNS3, which is amazing to me because the fact that it's free, as far as I know, it's free, right? And they continue to add functionality to it is pretty amazing. Um, yeah, I fully support it. I think it's awesome. So yeah, we've got here. Appreciate you sharing that too, DeBizzle, man. I love when people share latest news and talk about it because now I saw those posts, like I saw it on Twitter, and I subscribed to David Bombell's channel, and I saw that new video. I was like, okay, this is cool. Well, okay, great. But I didn't really think about how it could be used. And now after discussing with you here on the stream, I'm like, okay, I see how that's actually a cool thing. Um, okay, I'm not sure why. I just switched to router 1, and I thought it had already converged. Maybe that's an old message. Um, so on router 2 here, guys, we've got, so far so good. We got a type 7 advertising router is 4.4.4.4. Yeah, David is God. Uh, man, and his voice is so cool. I wish I had a voice like that. Um, and his video intros, man, they're very cinematic. It's just the music is just very enjoyable to watch, even though it's really technical stuff. Yeah. Um, I didn't know that. I kind of assumed that. I assumed that he had a CCIE and probably other certifications, because he seems like he's very, very knowledgeable. Um, I don't know if is he in Router Gods. I'd be curious. Yeah, it seems like he's a very seasoned engineer, from what I can tell. He's definitely inspiring to me, that's for sure. Um, and I just discovered his channel. I'm like, wow, who is this guy? He's awesome. Um, and that's great. The community, we have so many people producing, quality stuff like that. So yeah, this should be simple, right? We got LSA Type 7 advertising router. Then I should query my database and say, okay, show IP OSPF database router 4.4.4.4, and I could see here that he has a link to a transit network, and I happen to know, I mean, I don't know this topology that well, but I already pretty much know that this is me. Show IP interface brief. 002, yeah, so I'd still do like a network query because there's probably a designated router on this link. There is. Wait, that's on. Well, there's one on this one too. There's a backup designated router. I'm the designated router. But yeah, so I consult the two, but I basically conclude that um, TO0 metrics is 100. Yeah. So it should be 120. Now the question is, how about path number 2? Looks like I got path number 1 right so far. I haven't looked at the routing table yet. But path number 2, it says on in area 0, there should be a type 5. And there is a type 5. Metric of 20. Boarding address 0000, right? There's no. The advertising router is 4.4.4.4, which is interesting. So probably what's going to happen, I may have done this one wrong. So how does this work? Because I am in, let me just do a show IP OSPF database here. I want to see a summary, right? Yeah, type 5s really don't get assigned to an area, do they? However, if I'm router 2, yeah, I'm going to query. So I'm not even going to go this way. Because the forwarding address is this, so yeah. All right, so let's see if I got this right. Let's do a show IP route 5.5.5.5. Yeah, that's NSSA external 2. That's what we said it would be, right? In 2. And the route metric is 20 and the forward metric is 100. So effectively it's 120. Because we have to add the forward metric. It's okay. It looks like I got that right. 24004, we know that is our next hop, the network link. Okay, good. We got that one right. We got the easy one. This should look the same, I would think, with the exception that there's no type 7. I don't know why I put types. Yeah, router 3 to router 4. We're going to have an LSA type 5 with the advertising router 4.4.4.4. What we saw basically on the other. Let's just look at it though. Show IP OSPF database external. Yeah, there it is. There's not going to be an NSSA. Yeah, there's no NSSA external. So yeah, we have our advertising router. There's forwarding addresses cleared, right? So all we have to do is calculate our link via the LSA1. OSPF database router 4.4.4.4. And this is going to be our link. Pretty much the same thing. So the metric should be 20 plus 10, 30. Let's see, show IP route 4.4.4.4. Or sorry, 5.5. There it is, 20. Now forward metric is 10, so that's right, I got it correct, 30. So this other business I was trying to figure out through area 0, what I was not considering is that the fact that when you have an LSA 5 sitting on this router, it's not going to have an area number assigned to it. So even though an area 5 comes this way and an area 5 comes this way, if it's the same advertising router, doesn't matter where it came from, you're going to have one calculation to get back to it. Okay, let's do this one before we do 4. Let's do number 1. So on router 1, which path and why? We calculated for path 1, and we said that we should have on router 1 an LSA type 5 with an advertising router of, so we're going to actually have 2 of these, aren't we? We're going to have 2 LSA 5s. We're going to have one is advertising router 2.2.2 because these are in different areas. As opposed to if these were in a single area, there would be a selection process as to who's the ASBR, right? Or who is the ABR that's going to forward it. But in this case, we're going to have 2 LSA 5s with 2 different forwarding addresses. This one, and they're both going to have a metric of 20. Then it's going to come down to calculating our distance, our metric to the advertising router. So let's look at the LSAs. Let's see, we got it. Show IP OSPF database external. And that is correct. We have, oh, we only have one type 5. Right, right. Okay, I got this wrong. Why did I say that the advertising router will be 2.2.2.2? Oh, the reason is because it said no conversion. Yeah, this is what I got wrong. See if I go show IP OSPF and SSA external. No type 7.5 translation. Why is this no 7.5 translation? This is what got me right here. Yeah, I'm not even, so there's no translation taking place. So router 2 is not even sending a router 5 or an LSA type 5. Why is there no translation? Oh, well, I'm stumped. Why is there no translation? Let's look it up. There was a configuration guide on this subject. Gotta go all the way back to support. Yeah, products. Yeah, now I'm in a different release. Oh, Cisco. See if I go this way. I'm going to actually get to 15.6. Just go back to the main page. Yeah, if I go directly to network software, get 15.6, but no, not if I go the other way. Strange. All right. IP routing OSPF. There is a conversion document here. Where is this document? We have to LSA filtering. I'm not finding it there. All right, let's go back to, and the back button doesn't work. All right, let me think about this. Why is there no type 7 to 5 translation? Yes, external link. Also done on this one. So if I'm in a not so stubby area, I should be allowed to advertise to generate external routes. I'm not going to generate a default route. But I'm not a totally stubby area. I'm a not so stubby area. Let me look at the configuration here. Show run. Area 2 NSSA, that's it. So we only have one path here, don't we? Yeah, I'm gonna have to look, guys. I'm stumped. Right, there's some interesting. Okay, they went ahead and referenced something in an RFC here. R4 prevents route R2 from translating the type 7 from area 2 to type 5 into area 0. This behavior is per this RFC. Find the section here. This is really, yeah, how was I supposed to know this? That's why you become a CCIE, right? Because you're supposed to know this stuff by the time you pass. All right, how do we make this bigger? Okay, going back to January 2003. Okay, I keep wanting to say NASA. I should just say NASA, AS boundary routers, may only originate type 7s into NSSAs. An NSSA internal AS boundary router must set the P bit in the LSA headers option field of any Type 7 LSA whose network it wants advertised in the OSPF domain's full transit topology. The LSAs of these networks must have a valid non-zero forwarding address. If the P bit is clear, the LSA is not translated into Type 5. That's not the section. Originating Type 7 LSAs. Yeah. When an NSSA border router originates both a Type 5 and a Type 7 for the same network, then the P bit must be cleared in Type 7 so that it isn't translated into a Type 5 by another NSSA border router. If the border router only originates a Type 7 LSA, okay. NSSA AS autonomous system boundary routers may only originate Type 7 LSAs into NSSAs, and that's what's happening. So we have router 4 is an NSSA ASBR. So it originates a Type 7, right? You can't have an NSSA ABR originate at Type 7, obviously. An NSSA internal AS boundary router must set the P bit in the LSA headers option field of any Type 7 LSA network it wants advertised. Right. The P bit must be set. That allows a conversion. This P bit is not set. That's why it says no Type 75 translation. The LSAs of these networks must have a valid non-zero forwarding address. Okay, the LSAs of these must have a valid non-zero forwarding address. Right. This is set to 0. Does this router not have, oh, I think this is the key right here. Show IP. Boom. Sneaky, sneaky, sneaky. So guess what, folks? This is the key right here. And you know, Brian McGann mentioned this in the video. Notice that our router ID is what? Well, no, that's not right. That's not right. Not what I thought. But we need to be looking at router 4, right? Show IP OSPF. Okay, 4.4.4.4 is our router ID. Okay, we have a valid forwarding address. This is an actual network address. So if the P bit is clear, it still doesn't say why. Okay, I think this is the key right here. This is what's highlighted in the INE lab key. When an NSSA border router originates both a Type 5 and a Type 7 LSA for the same network, this is it. Then the P bit must be clear in the Type 7 so that it isn't translated into Type 5 by another NSSA border router. Okay, that makes sense. So as we see here, router 4, let me get out my coloring stuff here. So he's going to send a type 5 this way, right? But he has to know that if he sends a 7 this way, that's fine. He wants this to be reachable inside the NSSA. But he doesn't want this to be later converted to a type 5, because then he has 2 type 5s going in different directions. It sounds like that's what the reasoning is. So he clears the P bit here so that this cannot be converted to a type 5. So router 2 can reach him, but router 2 cannot. So that changes kind of our dynamic here on our exercise, because what this means is that essentially router 1 is only gonna have a single. That's not very helpful there. So he's going to have LSA 5. LSA, can't type or write this thing. He's going to have a single LSA 5, and the advertising router is the ASBR 4.4.4.4. If he allowed this, I guess router 2 could originate an LSA 5, but he would have to have only if he could put in a different forwarding address. If he could put himself as a forwarding address, would that not conflict? But I can understand the reasoning here. Router 4 doesn't know that. When he forwards, he has to ensure that, we have a single LSA type 5. We don't want to have any loops. So this looks to be the key here, and I did not catch that. Okay, so that changes our answer here. Essentially, we have one route to get to this loopback. Now, the question is, what happens if router 3's interface to router 1 goes down? How does this impact router 1's path selection to router 5's loopback? He loses connectivity. Because again, now if this interface goes down, that's different. Now router 4 says, okay, you can translate this. It's going to go this way. How do we fix this scenario then? That's not a really good scenario. That's kind of a, we have a single point of failure here, right? So we have a failure domain we have identified, and we need to, how do we correct that? We could make this an NSSA as well, yes. Then he's not an, then router 4 is not an ASBR in an NSA area and a non in a regular area. That would probably fix it, but maybe that's not what we want to do. How would we fix that? All right, well, tell us, Aini. Yeah, I got the other ones right, it looks like. Is there bonus questions? Interesting, guys. This is doesn't really give an answer. Let's look at router 5. Sorry, router 1. Let's just confirm what it's saying here. They show IP route 5.5.5.5. Yeah, 4.4.4.4, and this is going to be our path, right? Show IP interface brief. 13. Oh. And I think it's telling me the answer here. Even with a modified forward metric of higher value, R2 will not choose to route through area 0. Yeah, he doesn't tell me, doesn't even give the answer. So, what we have to remember, very important, kind of a subtle rule, that if you have a router that is an ASBR in 2 different areas, and one of them is an NSSA and the other is not, it's going to clear the P-bit when it sends the LSA type 7 to the NSSA area. And I'm not sure what a solution. I'd be happy if anybody has any ideas. And I'm probably going to pose this. I may pose this in some of the discussion groups tomorrow because what would you do? Create a backup route? Maybe a floating? You could do, all right, let's do something like this. Let's test it. It's kind of cheating though, isn't it? First of all, you notice in this design that this is probably not a common design you would use anyway in production because what's the issue here? You have a single point of failure anyway because who's doing redistribution? We've only got a single router here. You've got one router doing redistribution. So you can't really engineer a very good failover scenario for this because you've already got some built-in failover here. Ideally, you would have another router, right? Connected to EIGRP. You'd have, and both of them doing redistribution. So yeah, I would kind of give up right there and say, yeah. I mean, I could put, for example, a floating static route if I really, if I was stuck this topology, and that's all I could do. I could put there's several ways I can handle this, right? But on router 2, okay, let's try it. Let's try to come up with something. Let's say IP SLA 1, and we're gonna do ICMP echo and the 5.5.5.5 and source interface. Let's do it from this interface here, which I actually don't know. to show IP interface brief. We want to source it from the link going to router 4, right? So that'd be this one here. So IP ICMP echo 5.5.5.5 source interface. No, let's say source IP 24.0.0.2. Okay. Then we say IP SLA schedule 1. Start time now. Track 10. Track 10. IP SLA 1. Let's do state. Okay, now we got our tracking options, right? Show IP SLA. Return code, number of successes, number of failures. Okay. Show track 10. Last operation return code. Okay. So we do tracking here. And no, that's not going to work, is it? Well, I guess we could do tracking here. What we'd have to see is if there was any failure on this link or this link. Router 2 would have to know. Actually, we're gonna have to do it a little simpler than that, right? So if router 1 can reach router 4, this interface, if for some reason he lost reachability to that, then we could put a static route. Yeah, let's do that way. That's the only way I can think of doing it. This is above and beyond what was called for here in the requirements, but we're getting adventurous here. We're practicing our SLA. IP SLA 20. And we're going to say ICMP echo. The destination is going to be this router 4. What is that? Show IP interface brief. 4 to 3 is this 34004. Source IP is going to be router 1's. Facing router 3 is going to be this guy. So P echo 4.0.0.4 source IP 13.0.0.1. IP SLA 20 start. No, IP SLA schedule 20 start time now. Track 10 IP SLA 20 state. Show track. Okay. Now, how do we do a route based on a tracked object being down? It's not going to work either, is it? So we do IP route. And this is going to be via, next hop would be router 2, show IP. Next hop would be this guy, router 2. Router 2 has a route to 5.5.5.5 to 12.0.0.2. Track 10. Yeah, it's not going to work, is it? Yeah, we're basically going to be overriding the dynamic routing protocol. I could do 255, that would create a null route, right? Yep, I'm not sure how to get around the scenario, guys. Oh, could do this. Here we go. Just get it at a higher administrative distance, right? Not to make it that complicated. Distance of, it only have to be higher than 110. We'll make it 200. Stripe route. Okay. That would work. But this is redistribution. Who knows how many other routes we might need to get to, right? Which would be messy. That's its whole purpose. But hey, we've only got one router to do it with. All right, so let's test this. Let's go to router 3. And let's say that interface goes down. And what did it say? If router 3's interface towards router 1 goes down. HGI 0, 1, 13, shut. So now, we have to wait for a convergence, right? No, we don't. Just clear it. Okay. Yeah, we only have one neighbor now. And our tracking went down. But, well, first of all, let's test. Okay, do we now receive a route in OSPF? Show IP OSPF database. That's probably aged out. Is the routing bit set? Well, I can't tell. LSA age 681. Yeah, that's going to go away. Okay, now my static route is taking over. and have reachability. That's the only way you can do it, really, to get around this scenario. And you'd probably make either both these NSSAs or neither of them NSSAs. And you could also get around, that's probably the better way to get around that scenario. Let's just try that out too. Let's take this out, which means now I have no reachability. Yeah, but let's come here, let's bring this back up. Fascia 0, 1, 13, no shut. And let's make this area an NSSA as well. Router OSPF 1, area 1, SSA. Let's go to router 3. All right, let's see what it looks like now. Show IP OSPF neighbor. Okay, we're full. Now let's do show IP OSPF database external. Yeah, now we have, okay. Now we have free advertising it. Oh, this is interesting. Yeah, we don't care. Let's just do okay. Yeah, now we have two. We have from 2 and from 3. And notice what happened to the forward address. What is that forward address? 3, okay. This is the forward address. Well, let's see, 3, 4, show IP interface brief. Yeah, this is the forward address here, that's the forward address there. So I think if I read correctly that what it will do is it will use an Ethernet link here. It will try to use an Ethernet link as the forward address, which it does, not the loopback. Advertising router's here, but that doesn't matter, it ignores that. This is the forward address. And then what we do is we calculate, we should have a summary for this. Show IP OSPF database summary. Yeah, advertising routers 2. So then we do show IP OSPF database router. And that's how we calculate the metric. And in both cases, it's 20 with a forward metric of 110. Yeah, and in this case, so this is interesting. And this is more of what we want, right? Now we have two NSSAs. We have equal cost because for type 2, it's 20 plus the forward metric. And because router 4 has added these, you know, it's basically added this interface and this interface as forwarding addresses. Now we have a good, we have equal cost multipath, which is good. I think it's the same if we made both of these regular areas. Let's do that. Router OSPF 1, area 1. What do we do? No? Yeah. And then router no area 2 NSSA. Let's hop to router 2. Router OSPF 1 no area 2 NSSA. And then back to router 3. No area. I think I already did it here. You're not. Okay. So let's wait for a little convergence time here. Looks like it has. Full. We're full there. Are we full on router 3? Full on router 2? I think we are. Yep, we are. So now should have 2 type 5s. External. Come on. We have 1. Right. We have 4.4.4.4 and no forwarding address. So however we can get to it. And we should have, let's see, show IP OSPF. Summary or AB. Yeah, so we have these ASBRs now. So I would look at the ASBR. I would see the metric here is 100 through router 2, and the metric through router 3 is 10. So then I would calculate my distance to each, and it would still come out the same. So I should have equal cost. And I do. Good deal. Very interesting. Was on the right track, but I did not remember the RFC, that rule. And I'm sure it was discussed in some of the videos, but I just missed it. Well, this is the last OSPF for a while. On slate coming up tomorrow again is most likely going to be, we're going to tear down VIRL and we're going to rebuild it on the new version 1.3, and we're going to play with the new bells and whistles. And then that leaves Thursday, BGP videos. We're watching BGP videos, getting ready for that, doing some reading, and I'll probably do a little review lab Thursday, maybe a couple review labs, and then Friday we might kick off BGP. Thanks for tuning in, guys. Appreciate having you. Hope you have a good night, and we'll see you tomorrow.